consider three-dimensional case. If the three-dimensional solid capital G is homogeneous, then the density rho is equal to mass by unit volume. Okay, then mass of the solid G equal to triple integral over G density function delta xyz dV. This is for inhomogeneous solid. Okay. Now in this case, the center of gravity is given by x bar, y bar, z bar. Now the formula for x bar is x bar equal to 1 by m triple integral over g x delta xyz dV, and y bar equal to 1 by m triple integral over g y delta xyz dV. Similarly, z bar equal to 1 by m triple integral over g z delta xyz dV. So this is for inhomogeneous solid. Next we can consider for a homogeneous solid. Now the center of gravity of a homogeneous solid is called centroid. Okay, so next we can consider the centroid of a homogeneous solid. Centroid means center of gravity of a homogeneous solid. So we have the centroid equal to x bar, y bar, z bar. Centroid of a solid. Okay, homogeneous solid. So this is x bar equal to 1 by v triple integral over g x dv, and y bar equal to 1 by v triple integral over g y dv, and z bar equal to 1 by v triple integral over g z dv. Now we can move to one problem. The question is, find the mass and center of gravity of a cylindrical solid of height h and radius a. Assuming that the density at each point is proportional to the distance between the point and base of the solid. So here we have to consider a cylindrical solid. Okay, so we can draw the corresponding figure like this. Now we can mark the region of integration. So this is our solid G. This is the solid G. Now here the equation of a circle with the radius a and center origin is x square plus y square equal to a square. So this is our circle, and here the height of the solid is h. So here you can consider this point as h. So here z equal to h. Here the height is h. So this is our required figure. Now, since the density is proportional to the distance z from the base, density is proportional to the distance z from the base, we have the density function delta of xy z equal to k into z, where k is the proportionality constant, that is always positive. Okay. Now, next we can consider the formula for the mass of the solid G. Now, mass of solid G equal to triple integral over G delta of xyz dV. Okay. Now here that is equal to triple integral now kz dz dy dx. So here you can see that z varying from here at this point z is 0. So z varying from 0 to the maximum value is h. So z varying from 0 to h. Okay. Now y. Here we have x square plus y square equal to a square. From that relation you can find y equal to plus or minus square root of a square minus x square. So the limit is like this. Now for finding the upper and lower limit of x, you can consider y as 0. So x square equal to a square. So x equal to plus or minus a. So these are the required limits of integration. Okay. Now we can do the integration now. Now this is equal to k is a constant, k into integral from minus a to a, integral from minus square root of a square minus x square to root of a square minus x square. Now z dz. Z dz means z square by 2, and that is from 0 to h, then dy dx. Now you can substitute the upper and lower limits. So you have this is equal to k into h square divided by 2. Then integral minus a to a. Now you have dy dx. So first you can integrate with respect to y, and you can put the upper and lower limits. So here this is equal to 2 times root of a square minus x square dx after substituting the limits. So this is equal to k h square integral from minus a to a square root of a square minus x square dx. Okay. So that is equal to k h square, then now actually this represents the area of the semicircle. Okay, so here we have that is equal to pi a square divided by 2. Here minus a to a, integral square root of a square minus x square dx is pi a square divided by 2. So this is equal to half into kh square into pi a square. So this is mass of G. Okay. Now here you can see that area equal to double integral dA over R, and this is equal to integral from minus a to a, integral from minus square root of a square minus x square to root of a square minus x square dy dx. This is the formula for finding the area of a given region. So here this is for the area of the circle. Now you can calculate its value as pi a square divided by 2. Okay, now here you can see that our figure is symmetric. Okay, that figure is symmetric about z axis. Now we can find now here we can find z bar only. Why? Because symmetry of the solid and the form of density function gives the center of gravity is on the z axis. Center of gravity is on the z axis. So x bar equal to y bar equal to 0. X bar comma y bar becomes 0. And so we can find the z bar only. So z bar is 1 by m triple integral over g z into delta xyz dv. Now that is equal to 1 by, the value of m is 1 by 2 k h square pi a square, and this is from integral minus a to a, integral from minus square root of a square minus x square to root of a square minus x square, then integral from 0 to h, then z into delta is kz, then dz dy dx. Okay, now you can do the integration and you will have the answer as 2h by 3. So the center of gravity is x bar, y bar, z bar, and its value is 0, 0, 2 by 3h. Okay, so this is the required answer.